Howdy folks. We're going to jump into the next section for our MAT095, which gets into chapter 6. Specifically, we're looking at 6.1, which gets into ratios. So to get things started, let's look at the definition. The definition of ratio is a comparison of two quantities with the same units. So that's pretty important. Now, the nice thing is that when there's no units whatsoever, then you don't even have to worry about it. So those are the nice cases. But in general, if we want to write a ratio, we can do so three different ways. We can write the ratio of 1 to 2 in words, just simply 1 to 2. Pretty lame, but it's one way. We can write it as a fraction, which is actually kind of the way that is going to be the most popular. So we're going to see that probably the most. And then there's also using a colon, and we have the 1 to 2 written with the colon. And you'll see that in various applications out in the world. Nursing likes to use that format. So we're going to stick with the fraction format though, because that is something we're kind of familiar with now. And so we're really just going to be applying some of the techniques we've seen back in the fractions chapter. So let's do a few of these. They'll go pretty fast for the most part. If we have something like this and it says rate the ratio as a fraction in lowest terms, okay, we know what lowest terms looks like. So we can write this one simply as 5 to 7. And can we reduce it? Nope. So we're done. Now something like this one, we can write it as 22 over 33, but now is this one lowest terms? And hopefully you're saying no, because 11 goes into both of those, so that reduces it down to 2/3. Now, technically we should say a ratio slightly different than we do fractions, so technically this is a 5 to 7 ratio. This would be a 2 to 3 ratio. So be careful. It's very easy to think of them as fractions, even though they're technically not. So anytime you have whole numbers that you're comparing, fairly quick to break them down. When you're comparing other types of numbers, then you got to be a little bit more careful. So something like this one, 1.5 to 2.4, we would still start it off the same way and put one over the other. But now the problem is we have these decimals in there. How can we get rid of those decimals with a nice quick multiplication? If we wanted to move that decimal point over one spot, we could multiply by 10. And that's going to move it over that one spot. So now we're dealing with 15 over 24. And now it's just like the previous ones. See if we can find that common factor to divide out and then reduce it down. So in this case, 3 is our common factor. So we end up with a 5 to 8 ratio. All right. Now, what about on different types of decimals? What if we had something like this? Well, we still, again, start off by putting one over the other. But now there's 2 decimal places that we need to get rid of. So what should we multiply this one by? And you probably nailed it. You got to multiply it by 100. So that's going to make it 245 over 325. So now, well, what goes into both of those for sure? Looks like a 5 will divide out of that. So 5 goes into that, what's that, 49 times. And the bottom looks like 65. So now can we reduce this any further? Probably not. Okay. So what about a combination of these two? I don't have a problem here, but let's just make one up. What if we said 1.5 to 2.45? We'll take a little bit of both of those two. How do we tackle this one? Well, again, put one over the other. But now what do we multiply it by? The top, all we have to do is multiply it by 10 to move it over 1. But on the bottom, we need to multiply it by 100 to move it over 2. So which one do we do? Always go with the bigger one. That way you're going to guarantee that they're both moved the same amount of spots. So in this case, we do want to multiply both of them by 100 again. So that'll give you 150 though on top, because we had to go 2 places, and the bottom's going to be the 245. So now, if we start to reduce this, well, let's do a 5 out of those. And if we divide the 5 out, looks like we're going to get 30 over what? 49. And so that's not going to really reduce down anymore. So that's your answer. Okay, so we've tackled a lot of different types of things. We tackled whole numbers, we tackled decimals. Now, we have something here with units in it. Now, the one thing we should notice is that the units do match up. We have the same ounces on both of them. So when we write this out initially, and we include those units, the one thing we're going to see happen is because those units are the same, they just cancel out. So the ounces are completely gone from the problem. So now all we have to do is reduce down to 4 over 12, which we know reduces to a 1 over 3. So we have a 1 to 3 ratio. No units. So ratio should never have units on your answer because they cancel. So, all right, what about fractions? Well, you still put one over the other. So if you got 1 1/4 over 1 1/2, how did we tackle those complex fractions in chapter 4? We had to divide, right? Now, to save us a little bit of time, let's change them to improper fractions and rewrite it. So 1 1/4 better become 5/4. 1 1/2 better become 3/2. And so now we have this, and now we can do our switch and flip. So that's going to give us 5/4 times 2/3, and now we can do a little bit of cross canceling. And then when we multiply straight across, we get 5 over 6. So 5 to 6 ratio. Okay. Let's take a look at a couple more, and then we'll take a pause. So we've got back to units again, but now we notice a problem. We're talking about time, but we got hours and minutes. So we got to do a little bit of fixing on this problem. Well, the rule, there's not really a rule per se, but the practice I would recommend is always change the one that's larger in units. So is minutes bigger than hours or hours bigger than minutes? We know minutes are smaller, hours are bigger. So we would want to change this into minutes. And the way we can do that is to multiply by however many minutes are in an hour. So if we multiply that by 60, we now have 60 minutes. So now our units are all the same, so we should be good to go. First number is always on top, second number is always on the bottom. So 12 minutes over 60 minutes, and the minutes go away. And then what's that reduced down to? What goes into 12 and 60? Well, it turns out 12 does. Oops. Make sure you write the right numbers. So 12 divided by 12 is 1. 60 divided by 12 is 5. So we got a 1 to 5 ratio. Okay, one more. Gallons and quarts. Gallons and quarts. So which one's bigger? Well, gallons are bigger than quarts. So this is the one we want to change. So now the question is how many quarts are in a gallon? Now, if you don't remember that, well, you can look online. But 1 gallon is 4 quarts. So now we know what to multiply it by. So if we multiply it by 4, we're going to end up with 20 quarts. Okay, so now first number's on top, second one's on the bottom. So 20 quarts over 5 quarts. Quarts go away. And so we end up with 4 over 1. 5 goes into both of those. Now, you might be tempted to say, oh, well, this is equal to 4, right? Well, it is, but you're not going to have a ratio anymore, because remember, ratio has to compare two quantities, two numbers. So we actually don't want to do this when we're talking about ratio. So this is our answer. It's a 4-to-1 ratio. So, okay, I'm going to keep going because we only got 2 more questions in this section. So let's keep going. Now, they're going to try to make it a little bit trickier by making it word problems and stuff like that, but we can do it. Find the ratio of the length of the longest side to the length of the shortest. Well, not shorted, shortest. Write the ratio as a fraction in lowest terms. All right, now in this shape, it's only 2 lengths. We got 1.8 and we got 0.3. Now, in your textbook, you might have other shapes that have multiple sides, like 5 or 6 or 7 sides to it. You still want to compare the longest side to the shortest one. So don't worry about the other ones, just look at the longest one and the shortest one. Now, which way do we write it? How do we write our ratio? We know which one's longest, we know which one's shortest, so which one's on top? Now the question says write the longest to the shortest. So the longest is on top and the shortest is on the bottom. So we got 1.8 meters over 0.3 meters. The meters cancel, which is what we want. And now, well, we got some decimals. How did we tackle those on the previous page? Because there was 1 decimal point, we can move it by multiplying by 10. So that gives you 18 over 3, which is 6 over 1. So this is a 6-to-1 ratio. All right, last one. An auto mechanic used to pay $10 for the 5 quarts of oil he needs to do an oil change. Now he pays $12.50. Find the ratio of the increase in price to the original price. Find the ratio of the increase in price to the original price. Now, if you look at this too quickly, your gut is saying, oh, just grab those 2 numbers and put them into a ratio and go. But you gotta be careful. The question doesn't want you to compare those 2 things. They want you to compare the increase in price to the original price. So what was the increase in price? It went from $10 to $12.50. So if we subtract those, so $2.50 is the increase. What was the original price? The original price is the $10. That's what it started at before it went up in price. So now we know what 2 numbers we're comparing. So don't let this information throw you off. They're trying to trick you a little bit. They want you to think. So they want the increase and the original. So $2.50 compared to $10. So which one's on top? First one's on top, second one's on the bottom. So the increase is first. So $2.50 over $10. Now, units cancel. So that's good. Now we got some decimals in here. So if you want to multiply by 100 to move it 2 spots, so that's 250 over 1,000. And I think 250 goes into both of those, right? So we end up with a 1-to-4 ratio. All right. So the next section is going to be very, very similar, but now we're going to look at the units that don't cancel out. So we'll see that in a minute.